Hello students, in this video we have last two questions of assignment 10.4. In previous videos we did derive expression for intensity in terms of x and d, and then we also had expression for position of bright and dark fringes on the screen. And in this video we'll address these two questions. First, what do you mean by stationary interference fringe? And how do we get it? And second, we'll see what is the width or distance between two consecutive dark or bright fringe. So before we go further, let us once again see the phenomena which produces interference pattern. As explained earlier, if we take two light sources and then if there is a screen, let's say distance capital D, let the sources be separated by distance small d. Sources are S1 and S2, and let the perpendicular bisector be SO. So on screen you will get pattern. Pattern means you will see that in some part intensity is more, in some part intensity is less. Again intensity increases, again it decreases. So overall, uh, what we get is regions of high and low intensities, and these are called interference fringes. Okay, so what I mean to say is that in this region you have more light, whereas this region is dark. Again you have region of uh, brightness, then again dark, and that is true even in the other part also. Okay, so this pattern of dark bright region is called interference fringes. Now, what is the condition for this interference fringes to be seen? The condition is that the intensity term has to be time independent. So if you go back to very first assignment, there you will see this equation that when you want to find out intensity of interference pattern, you should apply this formula. And then if you look at this cos delta term, delta is delta 2 minus delta 1, it is expressed as cos delta 2 minus delta 1 is expressed as cos of omega 2 minus omega 1 t minus k2 r2 minus k1 r1 plus phi 2 minus phi 1 dt. So essentially when you are talking about intensity over complete cycle, you are integrating cos term, and then it becomes cos, integration of cos over one cycle is 0. And what does it mean? That means that this term vanishes, and then the intensity I is I1 plus I2, which is not time dependent term. Intensity remains constant whether you are here or here or here. So it's not that interference is not taking place, but interference is time dependent interference. And the frequency is so high that visually we cannot differentiate between dark and bright regions, and so we feel that there is no interference taking place. If we want to have this kind of pattern remain there, means stationary interference, if you want, you'll have to remove this term, time dependent term. And how do we remove it? By choosing omega 2 to be equal to omega 1 and k2 to be equal to k1. Means if the sources are coherent, then the intensity will not be time dependent. Okay, bright region will remain bright, dark will remain dark. So what is stationary interference? Stationary interference is the pattern in which bright region remains bright, dark remains dark, intensity is not depending on time. And to obtain stationary interference, this condition must be satisfied. The sources should be coherent sources. Now, after this equation, uh, we have intensity equation for coherent sources, and then we have intensity equation for uh, position of dark and bright fringe. So let us see those equations. The intensity equation was I is equal to 4 times I0 cos square k r1 minus r2 by 2, and then from geometry of figure, if you remember, we did consider some point P. Okay, and then we have also had this situation where r1 minus r2 was compared with this triangle S2M, and we had one relation r1 minus r2 by 2. Now when I say r1 minus r2, it can be r2 minus r1 also, it makes no difference, so don't get confused about it. Is equal to, sorry, denominator is not 2, denominator is small d, is equal to x by d. And if I use this second equation, if I call it first, then we get third equation, which is again equation of intensity in terms of x and capital D, which is given as this. Now, what is the condition? How do I know that, suppose if this dark has occurred at say 1 mm distance, which dark I am talking about? First dark. Where I will get second dark? Can I predict where second dark will occur? So we know in last video we saw that for bright fringe, for constructive interference, the position can be given as n lambda. How did I get it? I have simply substituted n lambda in this case and made x subject of formula, because n lambda is condition for constructive interference. Similarly, for dark fringe, for position of dark fringe, I can write x as d by d 2n minus 1 lambda by 2. One thing you should not forget here is this n starts from 0, so it is 0, 1, 2, 3, whereas n here starts from 1, so it is 1, 2, 3. So don't get confused. Now, if I want to find out answer of this question, what is the distance between two consecutive dark or bright fringe? What to do? So what we can do is, suppose I am talking about fifth dark. So fifth dark, how do I give expression of fifth dark? So I will take 5 here, and then x5, if I label it, then it is 9 lambda by 2. Okay, and similarly, if 6 dark, if you take, what is the position of 6 dark? So position of 6 dark is x6 d by d 11 lambda by 2. In this equation, you may take n to be 6, and it will be 11 by 2 lambda. Now, distance between consecutive dark. So distance between 6th dark and 5th dark, what it will be? So I can write it as x6 minus x5, that is 11 by 2 d lambda by d minus 9 by 2 d lambda by d, and check the answer, it will be d lambda by d. Now actually this is not the proper way of concluding, because we have specifically taken case of 6th and 5th bright, but you can always take nth dark and n plus 1 dark. In that case, you will have n lambda here, and you will get uh, n plus 1, sorry, 2n plus 1 you will get, and then again you, if you replace these terms, you will end up with same result. Let us try out that. So position of nth dark, so let me label it as xn, then it will be d by d 2n minus 1 lambda by 2. And who is the next dark? So position of n plus 1 dark, that is x n plus 1 is d by d 2 n plus 1 minus 1 lambda by 2, which is nothing but d by d 2n plus 1 lambda by 2. Now distance between two consecutive dark, distance between two consecutive dark fringe, how do we find out? So it is nothing but xn plus 1 minus xn, that is d lambda by 2d 2n plus 1 minus d lambda by 2d 2n minus 1, and ultimately you will end up with d lambda by d. Sorry, this should be small d. What about bright fringe? So let us try that also. Position of nth bright fringe. How do I give position of nth bright? So it will be xn is equal to n d lambda by d, and position of next bright, that is n plus 1 bright. How do we express it? So it is let it be xn plus 1, that is n plus 1 d lambda by d. So what is the distance between two consecutive bright? So how do I get distance between two consecutive bright? Take subtraction of previous two results, so xn plus 1 minus xn. And at the end we end up with same result. So distance between two consecutive dark or bright fringe remains same, it is d lambda by d. So that was the topic. Thank you.